I'm going to do I'm doing a presentation on called SQLAlchemy Mappers Are Fun, and this follows on very nicely from Rick's presentation because I'm going to, I've been using SQLAlchemy Mappers for a few months now for a big project at work, and they've been working really, really well. And so basically what I did is I thought, all right, I want to show them quickly some practical ways of using SQLAlchemy Mappers. So I basically just opened up my mappers.py file, which is several hundred lines long and has all of them. So I just kind of paged through it, grabbing what I thought were the most few, for me, most frequently used features so that I could quickly just highlight them here and kind of show you how they work and how easy they've made my job. This is going to be more interesting for the people that watch the screencast because after you've seen the presentation, if you want to come back and find out where I got some of the functions and symbols I'm going to be calling, these are the import statements that explain to you where in SQLAlchemy they live. So come back and look at this, tomorrow or something, and you want to see where all the symbols come from. So I've divided this into 5 quick lessons that kind of ascend the steep staircase of using SQLAlchemy mappers. And kind of just outline the things I had to understand in order to use them effectively. And this will repeat in more detail, but hopefully not excruciating detail, many of the things that were already hit in Rick's slide. But the last lesson, the 5th one, is something he didn't hit. So you will get something new from this presentation. Lesson 1. When you map a class to a table, each database row in Python becomes a class instance, and each table column becomes an instance attribute. Now, I do really well with pictures, so here is, we'll pretend, a database table called person table, and that'll be the name we'll refer to it under in Python. We can see that inside the table it has 2 columns, one called person ID and name, and this particular table seems to have 3 rows in it. Person ID 1 is named Brandon, 2 is Persephone, and 3 is the person ID which refers to someone named Castor. These are my cats. Actually, shh. Now, this presentation is not about how you do SQLAlchemy table definitions. The table definitions are explained perfectly well on the SQLAlchemy website, in Rick's book, and so I'm just going to show you one so that you kind of have in your imaginations what these things look like, because all I'm going to show you from now on are pictures of tables like the one in the upper left. But if you want to declare a table with that structure, not the content, we'll get at that later, but that structure in SQLAlchemy, it looks something like this. You come up with a name like person table that you're going to refer to it by in your code. You instantiate a SQLAlchemy table object, giving it the name that the table should have off in the database, whatever metadata object you want it attached to. Again, see Rick for what one of those things is. And then you name the columns. In this case, obviously, the person ID is an integer, and it's pretty much implied there. It's going to be the primary key that we look up people by. And then we also have a column called name, which is text. So, understanding that I'm not going to explain to you how the tables get there, but they get there very much through statements like I just described. I'm going to look at how once you've got database tables, you hook them up to your Python classes. And just as Rick showed you, your class does not have to be special in any way. It doesn't have to know it's about to be hooked to a database. It doesn't have to inherit from anything. Right here, I have a little person class that just inherits from object. I don't even define any methods for it. It's just a container that I could set attributes on. And in order to hook the class to a table, all I need to do is call a single function called mapper that says I want my person class to be hooked up to the person table out in the database. And what does that mean? What that means is that I can do things like this. I can tell SQLAlchemy I want to do a query for a person, and I want you to only select the ones whose name is Persephone and return to me the one object that should retrieve from the database. What will the variable p be equal to after doing that query? If though it came from a database over in the table, a table over in the database, what I get back is one of my objects, one of my Python person objects with the attribute set to the values SQLAlchemy found in the database. Look, I can say p.personID and get back the number 2 because SQLAlchemy, with this tiny bit of code I wrote, just did all of the work of going to the database, retrieving the row, and for every single column in the row, setting the attribute equal to the value that it found from the database. So the .personID of this neat object I've just gotten is 2, and the .name, if we looked at it, would be Persephone. All of that happens for me. I just say I want the class hooked up to the table, and the values magically appear. That means that your actual application code does not contain the name of the table. Note that this little bit of code I just wrote that goes, grabs a person, and looks at some of its attributes doesn't mention the name of the table. That's the really neat thing about an object relational mapper. You do the mapping, and then you shut up about the tables and stop talking about them because they'll be touched automatically when they need to be. All right, this is the same class and mapping we did a minute ago. You can also query multiple things at a time. The earlier example just grabbed one object. Here I say query for person objects, but I don't put any constraint on it. I don't say limit it to person objects that begin with a particular letter or have a particular name. I let it grab all of them. So this little for loop, which this is working Python code, that says query for person objects and print their name will, without my having to lift a finger, well, except for the finger I typed that with, it will go to the database, grab all of the rows, instantiate them all as Python objects, copy into the Python objects the person IDs and the names from those rows, but all I know is that it appears to me as though objects magically appeared that had the same data as exists in my database. SQLAlchemy also handles when you do writes to objects. So here, I query for the person whose name equals Brandon. I get that one person object. And if I say p.name equals B Rhodes, now watch, everybody, watch the first column of the database. Are you ready? Boom! When I say session.commit, without my having to do anything, SQLAlchemy goes out, finds the right row in the table, and updates it so that the persistent copy of my object in the database row looks the same as I just made the person object look in memory in Python. If you create a new person and give it, there we go. If you create a new person and give it a person ID and a name, you just have to get your SQLAlchemy session and say, save this new person, and everyone watch the table. Boom! When you commit the session, a new row will be written without you having to write any more code than that. Similarly, you can grab, for instance, the caster object and say session.delete it, and watch the table. Boom! When I say commit, the row will be removed from the database. All of that happens automatically thanks to SQLAlchemy's plumbing. So mapping a class means that database rows become class instances when you look at them. Columns become instance attributes, and both reading and writing pull from and write to the database without you having to do anything extra. Lesson 2 is a fairly quick one. The next thing I learned was that foreign keys, which we'll show you in a second, are not special by default. SQLAlchemy by default doesn't treat them as special. They just look like integers or strings or whatever they are. Say I have two tables that look like this. So on the left is our familiar old person table with me, Persephone, and Castor in it. Over on the right, we have some accounts that have been granted, say at the business we're at. Two accounts have a person ID of me, BR32 and Brandon. So those are presumably, accounts I've been given. But Persephone, it doesn't look like she has any accounts because there aren't any accounts with a person ID of 2. However, Castor apparently got the account KDog, and because you see his person ID is 3, which refers to Castor. That's what a foreign key is. It's when over in an accounts table, you have a column that's giving the reference numbers of some other object and establishing that there's some kind of ownership or other relation between them. The naive way of just doing a quick mapping of these tables is make a person object, make an account object, say call the mapper function twice to turn your person objects into live representations of rows from the person table, make your account objects live representations of rows from the accounts table, and then you can do things like A equals query account, filtering by name equals kdog, and so A, of course, what you get back is an account object over in your Python land. Its account ID is 3, and also its person ID is 3. Well, that's kind of annoying. The whole point of having a person ID was to get over to a person over in the person table, and instead it's just an integer. If I want to get the person referenced by that integer, I've got to do my own query on person, filter by person ID equaling the a.person ID that I just looked at, which is 3, and only then, after I've done that second query, will it give me the name caster back. So lesson 2 is simply that foreign keys, by default, are just going to look like integers or strings or whatever their type is. They're not going to magically get you over to the other object until, of course, you get to lesson 3, which is you have to explain to SQLAlchemy with something called a relation that you want foreign keys to become a live way of getting you over to the other object. When you create a relation, you're creating an extra magical attribute on your class. So here, the person class and the person mapper look the same as before. We're going to focus on the account class. No, we're not, because it looks the same as before. I guess the only difference here is the account mapper. It says account, all right, it said that before. Account table, it said that before. The difference here is that we're giving the mapper function the properties attribute, and we're giving it a little dictionary with one thing in it. These are simple examples tonight. And what we are doing here is declaring a fourth attribute that we want to be present on the class rather than just the 3 real ones. I mean, we've already established the examples that an instance of account is going to automatically get copied onto it, the account ID, the username, and the person ID that come in from the database. What I'm doing with that properties parameter is I'm asking for a new magical fourth attribute to exist on the class in addition to account ID, username, and person ID, and I'm just calling it person. And I'm asking SQLAlchemy, make it a relation to the person referred to in the foreign key. And SQLAlchemy is pretty smart. It'll figure out, oh, look, it's a person ID. I'll bet that's supposed to point over it. And this is all you have to write. If you set up the foreign keys properly, it automatically figures out which table it references. And that means that when I get my account named kdog, and now same as before, a.person ID is still the pretty useless number 3. The magic here is that now if I use my new attribute I've defined and say a.person, I actually get the person object back without having to do a second query. SQLAlchemy goes out and does that second query for me. So all I've got to do is get an account A, and down there at the bottom say P equals a.person. It goes, it does the query for me, and results in P being a person. And so here, like as I explained before, you can ask it for any of its columns like name, and you find out the name of the owner of the kdog account. Here, if we grab the account username br32, look how simple this code is. I just say a.person, which invokes all that complicated SQLAlchemy stuff that grabs the foreign key, goes to the other table, instantiates one of my classes, and gets the row. And so I can then just call .name on the result. Again, it looks from this end as though it's all just objects connected together like you normally would in Python. You get to forget about the fact that there's tables there, except when your boss asks where's the data, and you get to point at his expensive database and say it's right there where you can get it anytime you want. Here I grabbed the person named Persephone. Oh, and this is just illustrating that these attributes are also writable. I can say a.person equals a person I've just looked up. And all right, everybody watching the, okay, this is the BR32. Everyone watch the upper right-hand corner. BR32 is currently owned by Brandon. We're about to do a commit. And boom, SQLAlchemy saw, oh, well, he set that account's person to Persephone. That must mean that he wants me to go and set the person ID of that row to Persephone's person ID, which is 2. That all happens behind your back automatically. We change the magical relational attribute .person whenever we want. SQLAlchemy takes care of going and setting the actual .person ID integer that lies behind it. You can establish, as was shown, relationships in both directions. A very naive way that I kind of used at first is to say, we've already said on the account that we want it to have a new person attribute. Well, we can also say on the person that we want it to have an accounts attribute, and SQLAlchemy will figure out that, oh, well, a person can own several accounts, because as here, it's perfectly fine for multiple accounts to point at Brandon as their owner. So p.accounts will be a list. You can see that here when I look up Brandon and look at p.accounts, rather than before, where .person always returned a single object, SQLAlchemy knows that .accounts needs to be a list of 0 or more objects, depending on how many rows it finds matching the person ID of the object I'm talking about. So here I loop over them and print out the account names of the objects, and I can even do something like, for each person in a query of all the people, print the person's name and a list showing all the accounts, just like I'm talking about Python objects, and it whips through those. I never have to see the SQL it generates. I just get out all the values. So that's the magic of doing a relation, is it lets you get an idea of an object and forget about it and just jump right over to the object itself. Lesson 4 is quick, and it's just the fact that the real way of doing this is generally, instead of telling a person that it has accounts and an account that it has a person, you typically just name the relation once. I usually put it on the table that actually has the key, so I remember where to go find it later. And instead of telling a person it has accounts, down here where I set up the relation to person, I say backref equals accounts. And that means, hey SQLAlchemy, at the same time as you're setting up my account to have a .person, go ahead and set up my person to have a .accounts that points back in the other direction. And I think you indicated, Rick, that it's able actually to synchronize things better when you do it as a backref than as 2 independent lists. So when you do things that way, what does that mean? Attributes now defined. Oh, you get to keep the attributes all in one place. Going back up one slide, we just get to put in one place all of the details of what we want it to do with that person ID up there. SQLAlchemy can keep both ends of the relationship synchronized. The one thing I don't like about it is that by looking at a class's mapper, you can no longer see all of its attributes. Here I compare the 2 ways of doing things. Again, option 1, SQLAlchemy can't manage it as well, so you shouldn't do it that way. But darned if I don't like being able to look at the person mapper and know all of the attributes my person has. The problem I found maintaining code done the right way with option 2 down there is that if I look at my person mapper, which here has no attributes listed, that's not the whole story. I have to search through my whole, at this point, several hundred line file for everywhere that person exists, because any other table that establishes a relation back to person might declare a backref. And wherever someone else declares a backref means that the person object gets a new attribute. So if I want to sit down and document the person class for my fellow programmers and list all the attributes it has, I have to look everywhere in my file that person is mentioned, rather than just being able to look at its mapping. So back references, you don't have to map both ways. It can keep it better synchronized, but it does mean that any place in your code you could be declaring an attribute on one of your classes. We now get to the really fun thing, which is kind of the focus of the presentation. SQLAlchemy has something really, really neat called an association proxy, which you can use to go grab not objects, but really simple data inside of database rows that you want to be able to get at. Let me explain. Let's imagine we're setting up one of those photograph organizing applications where people, load in all the stuff they've taken with their digital camera. And what do people do these days? They don't put them in folders anymore. They add tags because that's multidimensional. So on the left, we imagine we have a table of photos that maybe keeps the file name and then some unique ID so that we can keep up with the photo even if they rename it or modify it. And over on the right, we might have a tag table that for each photo ID can list 0, 1, 2, any number of tags. In this case, 2 tags have been put on the picture of the mountain and 1 tag each on the sequoia and the sunset pictures. So a simple mapper would have a photo object, to represent each row of the photo table, a tag object to represent each row in the tags table, and then the mappers would look like this. Photos are backed by the photo table, tags are backed by the tag table, and of course we want some kind of relation like tags on a photo, which will let us quickly see all of the rows from the tags table that are associated with that photo. That means that if we say, query the photos for the photo ID number 1, maybe the user's just clicked on it or something, and then we say p.tags, what do we get out? Well, according to everything I've told you about SQLAlchemy, its object relational mapper, what we get out when we say p.tags are tag objects. One of which presumably is the row 1 landscape, and the other of which is the row 1 comma vacation. And that's a little bit, honestly, that's a little bit annoying. Look how simple a row of the tags table is. Clearly, the only purpose that the tags table exists for is to keep little pieces of text. But when I say p.tags, I don't get back my little pieces of text I need to display. I get back these objects that have a photo ID and a tag attribute on them that I've got to look inside if I actually want to get to the text. This makes for just kind of an ugly code because if you say, look at photo number 3, its .tags is going to have a list showing the 1 tag, Montana, I guess, that it got back, but of course it's a tag object representing that whole row, the 3 and the Montana. So if I grab that tag by grabbing the first element, the only element, out of p.tags, then it is a tag object, and I've got to say .photoid, .tag, if I want to be able to look at what it is and display it. And I'm not going to show you, but things get only worse if the user enters a new tag, because you can't just throw the string into the object. You've got to go create a new instance of tag and set the ID to the right thing and set the tag to the right thing, or make sure you add it to the right collection. And your code just winds up being really wordy and a bit difficult to maintain. How can we hide all of those horrible, horrible tag objects so that photo.tags simply returns a list of strings? Well, let's look back at this, and this is the only time tonight that you will see me actually make a class that has something inside of it besides pass. Because the way association proxies work is they're actually a property that you're adding to your class. This is interesting because I think they work even if your other attribute is not backed by SQLAlchemy, but that's a complex and mysterious question, so don't pay attention to what I just said. Now, notice what I've done first down at the bottom. Because I don't care about and I don't want to see these dang tag objects, I've renamed what used to be called tags down there on the mapper to something far less appealing that hopefully I and my fellow programmers won't be tempted to touch. I call it tag rows. because that's what you get through this relation to the tag table, is you get out whole rows with that useless photo ID, because you know what photo you're looking at, and then the tag string hidden down inside of it. So I've given that the rather less appealing name tag rows. And then the magic. Up here in my photo object, I've given it what turns out to be a property, which means a magical attribute. You try to get it and set it, called tags, which is an association property that every time you try to touch the collection tags, it goes into the real attribute tag rows and only exposes the .tag attribute of each of those objects. I'm telling it, when I ask for the tags, go into tag rows, which is a list of objects, and grab the first one's .tag, landscape, the second one's .tag, vacation, and just show me those. This is the result. Thanks to that one line I added to the program, I can now write this. The one line I added to the class. I can query for photo number 2 and just say photo.tags, and it gives me a list with vacation in it. I can say p.tags and just treat it like a normal Python list. Append tree. Okay, watch it. Boom! When I commit, whoa, didn't do that. When, and of course, this all made so much sense when I wrote it. Of course, you don't tell the object, you say session.commit. When I commit my, excuse me, there. And when you commit the transaction, you're now like 3 layers deep, so I won't go through all of the stuff that happens because you'll fall asleep. But SQLAlchemy has taken care of going and adding a row to the table when I merely expressed the fact that I wanted a string added to a collection of strings. I can then say photo.tags remove vacation, and boom, when you do session commit, okay, sorry, let's go back one slide. All right, everybody watch the upper right table. Boom, the row disappears for you. You asked for a string to disappear from a list, and it went out and made a deletion to a row in your database. I can grab, okay, that looks the same, getting photo ID 2, and its tags now say tree. I guess that was just showing that if you go and select it fresh, the new data is there. A lot of point to that. All right, so to conclude, we've seen that mapping makes class instances over in your Python world represent table rows, where when you change stuff in Python, real changes get made out in your database. Lesson 2 was that foreign keys by default just look like integers. They're not much use to you until lesson 3, you use a relation to create a new attribute kind of on top of and that gets you out of having to look at the ID attribute that actually goes and fetches an object for you. Lesson 4 was that back references prevent your having to mention a relationship twice, and that finally association proxies let you, for very, very simple database rows that like only have one thing in them you care about, an association proxy will let you get the data out and just talk about the list of datums rather than having to talk about objects. Other features that I could have prepared little slides like those previous ones to illustrate, but they're pretty simple concepts, and many of them, probably all of them, are mentioned in the book. You can, as he mentioned, you can use sets rather than lists. You saw everything I did here was with sets. You noticed I was dot appending and dot removing things. I actually in my programs never use lists because lists have orders and relational database tables don't. You can do the same query twice and get things in a different order because databases are built to be very, very fast, not to keep things in the same order you insert them. So I like having sets because it reminds me that the database doesn't think of the table as having an order. Relationships can get much more complicated. if the relationship between two tables isn't as easy as, oh look, there's a person ID in both of them, and maybe your DBAs, or like in my job, I'm talking to a database that was set up long ago. So some of the table relationships are a little strange because they didn't build it to have an ORM put on top of it. And that's what's so exciting about SQLAlchemy. It lets me get all this very rich and complicated data and hide it and just turn it into objects that act like objects. So when the join relationship isn't one that SQLAlchemy can guess because it's not a straightforward foreign key relationship, you can do one of those relation things and you can just tell it how to compare two rows to see if they belong together using that SQLAlchemy expression language that he discussed earlier. There's polymorphism. If your DBAs, as I actually did it myself, have a table with several kinds of objects in it, that you in your Python just want one row to become a person and one to become a guest, depending on some flag in the row, you can do that. And I will mention one annoyance. I didn't show you this, but when you...
Oh, yeah.
Is there a chapter on this?
I tell you what it does. I don't have any magic that makes you get it right.
You'll note that once I got to the point of introducing relations, I stopped talking very much about deleting objects. That opens a whole can of worms because if you delete the person Brandon, should his accounts go away, or do they simply become unowned and available for assignment to someone else? When you delete a photo, you probably want the tags to go away. Well, SQLAlchemy doesn't know in each case. So when you set up a relation, you have to give it this little parameter very often called cascade equals, and you give it some strings delimited very often by semicolons or commas that sort of tell it what you want to happen when stuff starts disappearing. And I don't understand them, and I fiddle with them until stuff seems to work, but it's not obvious to me what you, so I always just have to experiment. Well, setting cascade equal to all didn't work. All comma delete didn't work. Oh, all comma delete dash orphan did. I wonder why. And I never know. So that's like, if anyone could do a presentation on that, I'd really enjoy that. SQLAlchemy, by letting me get complicated relationships in databases and turn them into pretty dang simple Python code, has saved me tons of time and has made my Python code that runs on top of databases a lot more fun to write. Thank you, and are there any questions?
What is the database that you're actually connecting to, Postgres?
All right, in my instance, all right, I, like about a year ago, really got into this writing test cases thing. And I've been writing test cases probably for about actually 3 or 4 years now. And it used to be that I would like set up I would have to have an environmental variable which named some database name in my cluster that I knew was free, like Brandon_test. And I would have to delete it in PostgreSQL, create all the tables, run my tests. And that was just a mess because I had to have a connection to my database server from my workstation, among other things. So for this last project that I did with SQLAlchemy, because SQLAlchemy lets me write Python code once and then talk to multiple kinds of databases, I used the magic fact that SQLite, which normally puts your database in a big file, it writes on disks, SQLite is willing to run a database out of a block of memory instead. You ask it to open the file, :memory:, I think is the magic Nintendo game controller code you give it. And it, instead of writing to disk or opening a file or requiring write access anywhere on the system you're on, will actually just create a block of RAM and put all your tables there that go away when you close the database connection. So I have been using PostgreSQL for my production. I need a database cluster on a highly reliable system and connect it because I really like PostgreSQL's performance. It has a beautiful design. I really like it as a database. But when I want to do a unit test, I just want, for the brief moment my test runs, the database to appear in memory, get some data in it, the test does its thing, and then get closed down. So my test code always runs against SQLite databases, and my test harness creates a little new SQLite database for every test that runs, and it takes essentially no time.
I wonder what sharding would be like with SQLite.
A waste of cycles,
Probably.
particularly if you're in memory mode.
Any other questions? All right, thank you very much.